let A equals to 2, 5, 6, 8 and B equals to 5, 7, 9, 1. Then find A union B. A union B equals to, set A we have 2, 5, 6, 8 union, set B we have 5, 7, 9, 1. So A union B, union, we need to write all the elements from set A as well as set B. So first let me write all the elements from set A. In set A we have 2, 5, 6, 8. Now we need to write the elements from the set B. Here set B, first element is 5, but already we wrote 5, so I am not going to repeat it. Next 7 is there, so write 7. Then 9, write 9. Then 1, write that 1. So A union B equals to 2, 5, 6, 8, 7, 9, 1. Example 2 is, let set A equals to A, E, I, O, U and set B equals to A, I, U. Then he's asking us to show that A union B equals to A. A union B equals to, set A is A, E, I, O, U. Union, set B is A, I, U. Okay, let us write this union first. So write all the elements from set A, that is A, E, I, O, U, comma. Now elements from the set B. A already I wrote, I already completed, U already completed. So nothing is there to write more. Then A union B is nothing but A, E, I, O, U. This A, E, I, O, U is the same as this set A. So which is equals to set A. Then A union B is exactly equals to set A. Next, if set A equals to 1, 2, 3, 4 and set B equals to 2, 4, 6, 8, then find A union B. A union B equals to, set A we have 1, 2, 3, 4 union, set B we have 2, 4, 6, 8. We need to find the union, right? So first write all the elements from set A, that is 1, 2, 3, 4, comma. Now elements from the set B. Here 2 is there, 2 already completed, 4 is there, 4 already completed, then 6, 6, then 8. So A union B equals to 1, 2, 3, 4, 6, 8. Next, find A intersection B when A equals to 5, 6, 7, 8 and B equals to 7, 8, 9, 10. So he's asking us to write A intersection B. A intersection B equals to 5, 6, 7, 8 intersection 7, 8, 9, 10. So intersection is nothing but the elements which are common in both the sets. If we observe these two sets, here 7, 8 are common in both the sets. Only these two elements we need to write. 7, 8. Next, example number 5. If set A equals to 1, 2, 3 and set B equals to 3, 4, 5, then illustrate A intersection B in Venn diagram. So first draw one rectangle. This is for universal set. Set A, set B both are there, right? So two circles we need to draw. One is for set A and one is for set B. Now in both the sets, set A and set B, what are the common elements? Let us check once. Only element 3 is common. That element 3 we need to keep it here because that is the part which is common for both the circles. Next, in set A 1 and 2 are remaining, so 1 and 2. Then in set B 4 and 5 are remaining, here 4 and 5. Now in the question he is asking just to find out A intersection B only, right? So this part you need to shade. That's it. This is A intersection B. Next, example number 6. Let set A equals to 1, 2, 3, 4, 5 and set B equals to 4, 5, 6, 7. Then find A minus B. A minus B equals to, In the set A, we have 1, 2, 3, 4, 5 minus set B is 4, 5, 6, 7. So now what we need to do for this A minus B is first remove all the elements which are common. Remove completely. So 4 is common, then 5 is common. Completed. Now we are going to find A minus B, right? Only from the set A, we need to write all the remaining elements. Only from set A. From set A, we remains with 1, 2, 3. That's it. In case if you are finding B minus A, you need to write the remaining elements only from the set B. Example number 7. If set A equals to PQR and set B equals to QPR, then check whether A equals to B or not. So here two sets are given and he is asking to check whether those two sets are equal sets or not. What exactly equal sets means? If a set contains some elements and the second set also contains some elements. If these two elements are same, if the two elements are same, then those sets are called as equal set. Every element of set A should be there in set B. The same way, every element of set B should be there in set A. Then those sets are called as equal sets. In the set A, we have element P. In set B also, we have element P. In set A, we have element Q. In set B also, we have that same element. In set A, we have R. In set B also, we have R. So, every element of set A present in set B, every element of set B also present in set A. So, we can conclude that A and B both are equal sets. So, A equals to B. Next. If set A equals to 1, 2, 3 and so on and set N equals to set of natural numbers, then check whether set A and set N are equal sets or not. So, set A is given as 1, 2, 3, 4, 5 and so on. So, starting from 1, this is nothing but natural numbers, right? Next, set N is given as N is set of natural numbers. Natural numbers start from 1. So 1, 2, 3, 4, 5 and so on. Now if we observe these two sets clearly, here 1 is there, here 2 is there, here 3 is there, here 4 is there, here 5 is there. It continues like that only. Every element of set A is present in set N. Every element of set N is also present in set A. So we can say that set A and set N both are equal sets. Example number 9. Consider the sets. Set A equals to PQRS and set B equals to 1, 2, 3, 4. Are they equal sets? As I said already, every element should be same compulsory. For example, I am taking one element P from the set A. P belongs to set A. But this element P does not belongs to set B. P belongs to set A, but P does not belongs to set B. So, A and B both are not equal. Then what kind of these sets are? These sets are equivalent sets. If number of elements in set A, P, Q, R, S, 4 elements are there. In set B, 1, 2, 3, 4, 4 elements are there. If number of elements are same, then those sets are called as equivalent sets. Next, let A be the set of prime numbers smaller than 6. So, set A equals to set of prime numbers smaller than 6. 2, 3, 5. 2, 3, 5 are the prime numbers which are smaller than 6. Next, coming to the set B. Set B equals to B be the set of prime factors of 30. First of all, let us write all the factors of 30. So, 30 will come in 1 table, 2 table, 3 table, 4 table it won't come, 5 table, 6 table. Then 7 won't come, 8 won't come, 10, again 10, then 15, then 30. Now these are all the factors of number 30. But if particularly he is asking about only prime, 1 is not a prime number, next 6 is not a prime number, 10 is not a prime, 15 is not a prime, 30 is not a prime. So the prime factors of 30 are 2, 3, 5. So set B is equals to 2, 3, 5. Now observe these two sets clearly. Set A consists of 2, 3, 5. Set B also consists of 2, 3, 5. So all the elements are same. Then we can say that set A equals to set B. Both the sets are equal to each other. Example 11. Show that the sets C and B are equal, where set C is equals to X such that X is a letter in the word assassination. So in the word assassination, whatever the letters are there, we need to use those letters and we need to write the set. So capital A, comma, capital S, comma, capital S, comma, capital A. But in writing the sets, we have one rule, that is no element should be repeated. So once if we write S means no need to write it again. If I wrote one time A, then no need to write it again. Then A, S, S, A, S, S, I, then N, A already we completed, then T, I already completed, then O, N already completed. Next, coming to the set B. X such that X is a letter in the word station. S, T, A, T already completed, I, O, N. Then he is asking whether these two sets are equal to each other or not. Let us observe here. Here S element is there. Here T element, A, I, O, N, N. Every element of set C is there in set B. Every element of set B is there in set C. So both the elements are same. Then we can say that set B equals to set C. Both the sets are equal sets. Consider the sets. This is empty set. Set A is given as 1, 3. Set B is given as 1, 5, 9. Set C is given as 1, 3, 5, 7, 9. Then he is asking to insert subset symbol or not a subset symbol. So let us check once whether which one we need to use. First one, empty set and set B. Empty set is a subset of every set. So no need to check what is present or not present also. Empty set is a subset of every set. Next, set A and set B. If you observe, in the set A, element 1 is there. In set B also element 1 is there. In set A, element 3 is there. But in set B, element 3 only not there. So A is not a subset. Next, A and C are given. In the set A, 1 is there. In the C also 1 is there. In A, 3 is there. In C also 3 is there. So definitely set A is a subset of set C. Next, B and C. In set B, 1 is there. In set C also 1 is there. In set B, 5 is there. In set C also 5 is there. In set B, 9 is there. In set C also 9 is there. Every element of set B is present in set C. So B is a subset of C. Next, state which of the following sets are finite set or infinite set. What exactly this finite and infinite set means? If a set contains countable number of elements, then that is called as finite set. In case if a set contains uncountable number of elements or infinite number of elements, then that set is called as infinite set. So let us check this now once. He is saying that X such that X belongs to natural numbers, X minus 1 into X minus 2 equals to 0. So let us simplify this first. X minus 1 into X minus 2 equals to 0. Here X minus 1 and X minus 2 are factors. So first X minus 1 make it equals to 0. then x minus 2 make it equals to 0. Minus 1, if you take another side, it will become plus 1. So x is equals to 1. Minus 2, if you take another side, it will become plus 2. So x is equals to 2. Then x values are 1 and 2. Only 2 elements are there. Only 2 elements. So the set we can write it as 1, 2. If only 2 elements are there, means definitely this is a finite set, because I can able to count how many elements are there. Next, x such that x belongs to natural numbers and x square equals to 4. So that equation x square equals to 4. X square is 4, then what will be the x value? Plus or minus 2. But in the question he is clearly saying that x belongs to natural numbers only. Plus or minus 2 we have, right? Minus 2 is not a natural number, then x is equals to plus 2. So only one element is there. Again it is a finite set. Next, x such that x belongs to natural numbers, 2x minus 2 equals to 0. 2x minus 2 equals to 0. Take minus 2 to the right side, 2x is equals to 2. Take 2 also to the right side, x is equals to 2 by 2. 2 will get cancelled, then remains with 1. So the set contains only single element. Again this is also finite set. X such that x belongs to natural numbers and x is a prime number. So prime number start from 2. 2, 3, 5, 7, 11, 13 and so on. Because in the question he didn't mention that prime number less than 20, less than 30, less than 100, less than 1000. He is not saying like that. He is saying just it is a prime number. So prime numbers are uncountable. So this set will become infinite set, because we couldn't able to count how many prime numbers are there. X such that x belongs to natural numbers and x is an odd number. So odd numbers we need to write 1, 3, 5, 7, 9, 11, 13 and so on. So this is also uncountable number of odd numbers are there. So that's why this set is infinite set. Next, example number 14. If set A equals to 1, 2, 3, 4, 5 and set B equals to 2, 4, 6, 8, then find n of A union B. So what is this n of A union B? First let us find out A union B, then I will discuss about this n of A union B. A union B equals to 1, 2, 3, 4, 5 union 2, 4, 6, 8. So first let us write all the elements from set A, that is 1, 2, 3, 4, 5, comma. Here 2 is there but already 2 completed, 4 is there already 4 completed, then 6, then 8. So A union B equals to 1, 2, 3, 4, 5, 6, 8. Now n of A union B. This means number of elements in A union B. In A union B, how many elements are there? 1, 2, 3, 4, 5, 6, 7. 7 elements are there. So n of A union B equals to 7.